In this video, we're going to see how we can use Rolle's theorem to determine how many zeros a function has. Or another way, we can use Rolle's theorem to show how many solutions we have for a given equation. So we're going to see this with an example. So we're going to prove that the equation x cubed plus x minus 1 equals 0 has exactly one real root. As a complex polynomial, it has three complex roots, but if we stick to real solutions, we only have one real root. So how can we do this? Well, first, we're going to show that there exists at least one solution, and then we're going to show that that solution is unique. So for the existence part, you see, we're going to use the intermediate value theorem to show that a root exists. To do this, well, we're going to take f of x equals to x cubed plus x minus 1, and we want to show that there exists a point c such that f of c is equal to 0. And you see, we know that f is continuous on R, and we know that f of 0 is -1 and f of 1 is equal to 1. So f of 0 is negative and f of 1 is positive. We know that our function, as I said, is continuous on R, so in particular, it is continuous on the closed interval 0, 1. And then the intermediate value theorem tells me that I can find a point C between 0 and 1 such that f of c is equal to 0. So that tells me that the equation has a root. Now, I need to show that this root is unique. And this is when Rolle's theorem is going to help us. You see, to show that the equation has no real root, we're going to use Rolle's theorem. And the way we do it is we're going to suppose that we have two roots, a and b, and we're going to try to get a contradiction. So f is a polynomial, so it is differentiable on the open interval ab and it's continuous on the closed interval ab, because polynomials are continuous everywhere. Now, f of a is equal to 0 and f of b is equal to 0 because we're assuming that both a and b are roots of this polynomial. But you see, now we have all the three conditions that we need for Rolle's theorem. We know that the function is differentiable on the open interval ab, that the function f is continuous in the closed interval ab, and that f of a is equal to f of b. How? Okay, so Rolle's theorem tells me that there exists a point c between a and b such that f prime of c is equal to 0. But now let's take a look at the derivative of my function f. Well, the derivative is 3x squared plus 1. X squared is always greater than or equal to 0. So 3x squared plus 1 is greater than or equal to 1 for all x. So in particular, it is impossible that this derivative is ever going to be 0. So this is a contradiction, and that allows us to conclude that the equation cannot have more than one real root. And this is how we use Rolle's theorem to show uniqueness of solutions. Sometimes we want to show that we have only two roots. Try to see how you can create a scenario where you can prove